Good morning. This is Ms. Billerbeck, and this is the final lesson of Singapore Math 7. So we're on 17.4, and we're going to do further probabilities. So let's consider choosing 2 M&Ms from a package if there are 4 oranges, 3 greens, and 2 blues left in the package that you're eating. What is the probability that the first M&M is green and the second M&M is blue if you ate the first one and did not replace it? Okay, so this is very important. Did not replace it. That changes the way we do things. So you have to be very careful when you see that. All right, so let's look at the situation. So our sample space, the number in our sample space are 4 oranges, 3 greens, and 2 reds, which is a total of 9. So if we have 3 different branches, orange, green, blue, I'm sorry, that's blue, not red, then we have 4 out of 9 are orange, 3 out of 9 are green, which reduces to 1/3, and 2 out of 9 are blue. So we want to see what the probability is of eating a green one first and a blue one second. So when we set up these trees, we can set this up. So this one means that you ate one of the oranges. So there's one less orange, and there's also one less in the sample space. So it's 3/8. This one, you have only 3 greens out of 8. And this one you have 2 blues still out of 8, which reduces to 1/4. This branch of orange, no orange was eaten this time because it was a green eaten first. So there's still 4 oranges out of 8 in the sample space, which reduces to 1/2. But if you're looking at the green, one of the greens was eaten. So there's only 2 greens left out of 8, which is 1/4. And then on this branch, the blue, which is what we're concerned with, there hasn't been a blue one eaten, so there's still 2 blues in there out of 8, which reduces to 1/4. On this branch, we have 2 blues out of 9 to begin with, and we haven't eaten any oranges, so there's still 4 oranges, but there's one less in the sample space. So there's only 8 M&Ms left, so that reduces to 1/2. There's still 3 greens, so that's 3/8, but there's one less blue now, so there's 1 out of 8 blues here. Okay, so we are concerned again about this branch here, green, then blue. So we are going to write this, the probability of green, then blue. So is the probability of green times the probability of blue, because these are independent events. So what we're going to do is multiply. So the probability of green then blue is going to be 1/3 times 1/4, which is 1/12. So after we did all this work of the tree diagram, it was really simple to do the problem, believe it or not. All right, let's look at this here. So we have box X, and it contains 4 red pins and 2 black pins. Box Y contains 3 red pins and 7 black pins. Rex randomly selects a pin from one of the boxes. What's the probability that it's a red pin? All right, well, let's look at this. All right, here's our tree diagram. So we have 50-50% chance of picking box X or box Y. So that'd be 1/2 or 1/2. because there's two boxes and there's only one X and only one Y. All right, so we look at how many red pins there were. So there were 4 red pins out of 6, so that reduces to 2/3. But there were 2 black pins out of 6. We are using black pins, yes. 2 black pins out of 6, which reduces to 1/3. So, so then we go down to this box. So there's 3 red pins out of 10 and 7 black pins out of 10 here. So let's look at what we're going to do. So our plan is we have X in the red box or Y in the X box we have a red pin, or in the Y box we have a red pin. So we are going to do the probability of the X and red plus the probability of box Y and red. So let's do that. So the probability of XR is going to be 1/2 times 2/3, which the 2's cancel, equals 1/3. The probability of Y and R equals 1/2 times 3/10, which equals 3/20. So now we add these two together. So the probability of XR plus YR, or YR, let me make that look nicer. Is going to be 1/3 plus 3/20. Now we're going to just have to do a simple process of getting a like denominator. So this gets us 20 over 60 plus 9 over 60, which leaves us with 29 over 60. And that would be our answer. So that's the probability of picking a red pin from either one of these boxes, 29 over 60. So it's almost a 50-50% chance. All right, let's go on to this next one about fishing. All right, so if we go fishing, then there's this pond with 50 fish. So we have, these are the number of fish that have this length. So the lengths of the fish are from 0 to 5 centimeters, little babies, and 5 to 10 centimeters, there's 15. 10 to 15 centimeters, there's 13. 15 to 20 centimeters is 8, and 20 to 25 centimeters, less than 20 to 25 centimeters is 4. So what's the probability if 2 fish were chosen at random? For the first condition will be both fish are they're greater than 5 centimeters and less than or equal to 15 centimeters. So that's this range here. So it's going to be B plus C. So basically they're both fish that are the same range. So it's the probability of B plus C and B plus C. So we're going to have to multiply those. All right, this one, to get a strategy, one fish was a baby and one fish was in this range. So D plus E. Okay, so there's going to be two possibilities. We could catch the little one first and the big one second, or we could catch the big one first and the little one second. So we have an and here, the little one first, the big one second, or the big one first and the little one second. So let's look at what that might be. So when we calculate our branches, this first branch at A, there's 10 little fish out of 50, which reduces to 1/5. For B plus C, there were 28 fish in that range over 50, and that reduces to 14 over 25. And then on this branch, D plus E, there were 12 fish that were big out of 50, and that would reduce to 6/25. So if we look at, if I caught an A already, I'd have one less, so that'd be 9 out of 49, because my sample space got smaller too. The middle range fish didn't change because I didn't catch any over here. So that's 28, just like this 28. But the sample space is smaller now because there's one fish less in the pond. And then that reduces to 4/7. D plus E was unchanged. It's still 12 fish that were very large in the pond, but there's 49 fish left to catch. So on this line here, we have 10 fish still that are very small in a pond of 49 fish. And then we have for B plus C, there's one less because we caught one of them already. So it's 27 over 49 here, and none of these large fish have been caught, so it's 12 over 49. For this branch, one big fish did get caught. It was caught. So we have 11 over 49. So there's one less on the top and one less in this pond. And then there's no less here. It's the same number, 28 over 49. And this one is the same number of the babies in the pond, over 49. So our first problem asks, what if we caught this range first and then this range again? So what we're going to do for that is multiply 14 over 25 times 27 over 49. And that's going to give us 54 when we reduce it all, because we can take a 7 out of here and a 7 out of here. Remember to reduce. It saves you a lot of heartache there. And that's over 175. Okay, so we can put the answer here. It equals, I'll move this over so I can write. Okay, so this equals 14 over 25 times 27 over 49, and that's going to simplify and equal 54 over 175. Okay, so now let's look at the other situation. So this one's more complicated. Okay, so we have two different paths. So if we do this path, we're going to have, let's keep it 10 over 50 for now, times 12 over 49, plus, and then we're going to have 6 over 25 times 10 over 49. Now, since we have to add these, we need the same denominator. So let's just take a 2 out of here and a 2 out of here, so we have 25 times 49 and 29 times 49. So that saves us some time. So then when we actually do this, this ends up 5 times 12 is 60, and then we have 1225 on the bottom. And then 6 times 10 is also 60 over 1225. So we have 120 over 1225, which equals, when we reduce it, 24 over 245. Okay, so the answer to our question, our last question of our lesson, is 24 over 245. Okay, so that was a very complicated problem. So if you understood that, you're doing very well. Well, you have a lovely day. Bye-bye.